Hello students, in this lecture we will see what are dimensions and we will study about dimensional formulae. Let us see what is concept of dimension. The length of an object is a concept which is clearly identified. It does not depend upon the methods of measuring and the units in which it is expressed. Measurements such as length, breadth, thickness all have common characteristic that they are lengths. So, what is the common thing all in them? They have one dimension of length. All these are lengths. In mechanics, the length, mass and time are taken as three base dimensions, and these are expressed by letters L, M and T as shown here. What is dimension of a physical quantity? Dimension of a physical quantity simply indicates the physical quantities which appear in that quantity. It does not give about the magnitude of the quantity. So what is the meaning of this? When we say that the dimension is L, we are able to understand that it is a length. It does not give any idea about how much long it is. Is it few centimeters? Is it few kilometers? We don't get an idea. We simply understand that it is a length, it is a distance. If a quantity does not depend upon any of these base units, the quantity is said to have zero dimension. A quantity which is represented as a product of two identical dimensions will have two dimensions of that unit. So let us try to understand this. A quantity which is represented as the product of two identical dimensions will have two dimensions of that unit. So, for example, now let us see area. What is area? It is say length into breadth. So, it is distance into distance. So, what is the dimension of this area? The physical quantity area, the dimension is L into L. L into L. So, the dimension is L square. What is the dimension of mass and time in the physical quantity area? Area, does it depend upon time? Does it depend upon mass? No. So what we can see, the dimensions of area. Dimensions of area. What are these? M to the power mass should be raised to the quantity 0 because it does not depend upon mass. Length, it is length into length as we have seen, it is L raised to 2. It does not depend upon time, T raised to 0. Right? So, the dimension of area are like this. So, in such a way, what will be the dimensions of volume? Does it depend upon mass? No. So, mass is not there. Does it depend upon length? Yes. Volume it is L into L into L. So, it is L raised to 3. It does not depend upon time. So, these are dimensions of volume. Thus, we can say that dimensions of a derived unit are powers to which the fundamental units of mass, length, and time must be raised to represent it. So, suppose if for a derived unit, for a physical quantity, for a derived physical units, it depends upon 8th power of mass, it depends upon bth power of length, and the power of time is c. Then the dimensions of this physical quantity can be written as m raised to a, L raised to b, T raised to c, or this also can be written in a single bracket, m raised to a, L raised to b, T raised to c. So, for example, we will take one more example, say velocity. Velocity depends upon distance upon time. So what will be the dimensions? It depends upon distance. It is length raised to power 1. Time. Time is in the denominator. So its power is -1. So what are dimensions? This can be written as, does it depend upon mass? No. So the dimension of mass is 0. L raised to 1. T raised to -1. One more example, say density. It is mass upon volume. So what are the dimensions of mass here? It is in the numerator, to the power 1 it is, so it is 1. L, length is involved here? Yes, it is volume. Volume is length into length into length. So the power is -3. Length into length into length. Right? So, and the T, does it depend upon time? No. So the dimensions are m raised to 1, L raised to -3, T raised to 0. The physical quantities can be classified into following 4 categories. The first is dimensionless or non-dimensional variables. The quantities which are variable, they are changing. Time to time they are changing, but they don't have any dimension. They don't depend upon any of the fundamental quantity. These are called as dimensionless variable. What are the examples of these? So we want the quantities, they don't have dimensions. Obviously, they will be ratio of the same quantity. For example, angle, we have seen that d theta is equal to ds upon r. Both are distances, length of arc divided by radius. So it will be dimensionless. The second is specific gravity. It is the ratio of the same identical quantity which will not have dimension. Strain. What is the strain? Strain is the change in the length. Change in the length divided by original length. So it is length upon length, it is distance upon distance. So its dimension will be 0, dimensionless variable. It will be efficiency of a machine. It will be output divided by input. So again, it will be the ratio of identical quantity. So all these quantities, they are not constant forever. They are changing, but they are ratio of identical quantities. They are ratio of identical quantities, like length upon length, power upon power. It can be length upon length again. So change in the length is length, original length is length. So this is again a dimensionless quantity, right? So these are dimensionless or non-dimensional variables. The second category is dimensional variables. They are varying time to time, but they have got some dimensions. So our quantities like force, like momentum, velocity, power. So these are all physical quantities which depend upon mass, length or time in some way. They have got some dimensions. So that is why they are dimensional variables. The third is dimensionless constant. So they are constant forever. They don't have any dimension, but they are constant forever. They are not changing time to time. So these are constant quantities, like as pure number 1, 2, 3 or a number pi 3.14. Which is constant forever, it is not going to change. So these are dimensionless constant. And the last category is dimensional constant. The quantities like velocity of light in vacuum. It has some dimension because it is velocity, it is distance upon time. It has got dimension. But is it going to change? No. Velocity of light in vacuum is going to have the same value, 3 into 10 raised to 8 meter per second. It is constant forever. It has dimensions, but it is constant forever. So it is not going to change. So these are called as dimensional constant. So these are the types of physical quantities what we can classify into: dimensionless variables, dimensional variables, dimensionless constants, dimensional constants. Now we will see how to write dimension formula for a derived unit. A formula which indicates the relation between the derived unit and fundamental units. It is called as dimensional formula. It is an expression which will show how and which fundamental units enter into units of that physical quantity. So it will give us on which fundamental quantities this derived quantity is depending, how it is depending, which fundamental quantities are involved in that derived quantity, how they are involved. So this idea we will get from dimensional formula of a derived quantity. We will understand this better when we will see it for some of the derived units. For example, dimensional formula of velocity. We have obtained this in the earlier slide also. Dimensional formula for velocity. Velocity, dimension of velocity. Dimension of velocity will be equal to dimension of length upon dimension of time. So it is equal to L upon T. So it is L T raised to minus 1, or we can also write it as M raised to 0 L T minus 1. Acceleration. Acceleration will be change in the velocity. Change in velocity upon time. So, dimension of acceleration will be equal to dimension of velocity upon dimension of time. So it is, we have obtained it for velocity m0 lt minus 1 upon again t. So the dimension of acceleration are m raised to 0 l raised to 1, or you may, if nothing is written, means obviously it is power 1, t raised to minus 2. So this will be dimensional formula for acceleration. Let us continue to obtain dimension of force. What is the formula for force? Force is mass into acceleration. Mass into acceleration. F is equal to ma. I will write it. Formula F is equal to ma. So dimension of force will be equal to dimension of mass into dimension of acceleration. So dimension of force will be given by dimension of mass is m. For acceleration in the earlier slide, we have obtained it as lt minus 2. So finally, dimension of force will be m l t raised to minus 2. We will solve one more problem, like deduce the dimension of pressure. We know that pressure is equal to force upon area. So dimension of pressure is equal to dimension of force upon dimension of area. So we have obtained dimension of force mlt raised to minus 2, mlt raised to minus 2 divided by area. Area will be equal to, what will be dimension of area? Length into length. So dimension of pressure will be finally m L raised to minus 1, because this is 1, this is minus 2. Finally, it will be minus 1 T raised to minus 2. Dimension of work. What is work? Work is force into displacement. So it is dimension of force into dimension of distance. So force, we have obtained it, mlt raised to minus 2 into length. So it will be finally m L raised to 2 T raised to minus 2. In this way, if we know the formula for a physical quantity, it will be easier for us to obtain dimensional formula for any derived physical quantity. So, thank you, students.